Okay, so learning outcomes we studied for this topic, that is the developing schedule, chapter concepts, learning outcomes, and this topic is related to which areas of the project management body of knowledge. And then there was a slide about the estimating the activity resources, estimating the activity durations, and why is it good practice to have person who will be responsible for performing a specific activity estimate the duration for that activity. So that we also covered it, and explain the statement the estimated duration should be aggressive yet realistic. So today we will start from the here start from here estimate the activity durations. So in this case, first of all, we will determine the activity durations. Uh, you remember that the purpose is to create the schedule. Okay, when creating the schedule, which it means that we should know that at what time an activity should start and at what time the activity should finish. So for that purpose, we can create the network. Okay, but normally networking and scheduling are done simultaneously. Okay, at the same time. But for finding the at what time the activity can start and for what and the activity can finish, for we need to determine the duration of the project. Okay, so uh, this is the network, and this is the same example as we did before in the last lecture in the last topic uh, for developing the network. And for each of these activities, we need to estimate the duration. Okay, so the duration of the activity must be estimated, and then I think we just for the this is in fact one of the most critical tasks for in the project scheduling. Uh, the task of calculating the duration of the activities, the task of calculating when the activity will start and when the activity will finish depends on how we estimate the duration of the activities. Okay, so whatever is the duration of the activities, the starting and finishing time of the activities will depend on it. So this is very critical uh, because you can also see that uh, the calculating the duration of the calculating the start and finish time of the activities is more or less a mechanical or straightforward task. So once we have the durations, we can input into this network, and then we can easily calculate the those activity times. But how long the activity is going to take, there is a lot of information needed, which is in fact hidden in these boxes. So for example, in this activity, if we say that develop the draft questionnaire, so how many days it will take for us to develop, how many take for uh, how many days it we will take for us to draft the questionnaire. Okay, so it depends on the job, it depends on the type of the project, it depends on the type of the task, and it also depends on the number of resources available. So from one project to another project, or within a project, we will have different activities, different types of works. And then we have to consider each one of them to estimate the duration of the tasks or duration of the activities. So estimating the activity duration is the first thing, and then we can further perform the calculation. So after the duration of the activities have been established, we need to establish the project start and finish times. Uh, in this, first of all, define the overall window for project completion. So this is normally defined in the project charter, request for proposal, or there may be a certain deadline that may need to be achieved before which the project may be started. So for example, if the project is for some event for which the date has been fixed, so that will be the that will be the finishing date of the project, and then the project must be scheduled considering that event time. Or in another case, a client would say, a customer would say that, okay, I want this project to be completed within the next, say, 6 months' time. However, in many cases, we may not want to commit to a specific date because project not start until customer has approved the contract. That means from the contractor's point of view, a contractor may not want to commit to a specific date. That means this much, that means 1st of July 2021, okay? The contractor may not want to commit to that until the contract has been signed. In that case, the contractor will commit to this kind of situation. The contractor may say that would complete the project 7 months from the start of the project, or 6 months from the start of the project, but not to the specific date. Delay in contract signing may impact the project start. So this is one of the reasons. Yeah. So that's why the contractors normally would not commit to some specific date, okay, until the project has been signed. And set the finish time as the number of days from the project start. So this is how it goes. Uh, Develop the project schedule. So project prior activities for schedule development, and estimate duration for each activity, and establish overall window of time for the project. So for developing the project schedule, we uh, need to have a prior schedule and the duration for each activity. Okay. By prior schedule, we mean that a network diagram should be completed first. Okay. Or even at the same time, the duration of the activities can also be estimated, and establishing of the network diagram and the duration of each activity can be performed also at the same time. Develop the schedule timetable. So this is the next step. So this is the mechanical part for this task. Okay, that means when and after who, which activity will start. So earliest. So it will in this exercise you calculate the earliest start and finish times based on the estimated start date, and latest start and finish times based on the required completion date. So therefore we have four kinds of times. earliest start time, earliest finish time, and then later on we will see there will be a latest start time and the latest finish time. Earliest start time is represented by ES. Earliest finish time is represented by EF. And there is a relationship between the earliest start and the earliest finish time. The earliest finish time can be calculated as EF is equal to ES plus the estimated duration. That means you can calculate the earliest finish time if we know the earliest start time of the activity, and then we add into that the estimated duration. So if, for example, the activity is to start on Monday and the duration of that activity is 5 days, then the earliest finish time for that activity will be on Friday. Okay, because from Monday to Friday there are like 5 days, so that confirms our answer. So if 5 days plus Monday is the first day, so the project is going to complete on the fifth day. Okay, if the activity is going to take 5 days to complete. So, of course, there is this simple mathematics that is involved, and then that mathematics we will use to calculate the duration of the project based on some, in addition to some logical relationships between the activities in which the activity is connected in the form of a network. So calculate forward through the network diagram. So there is a specific type of terminology which is called as the forward pass calculation. So forward pass calculation means we move forward from the start of the project to the end of the project to calculate the earliest start and earliest finish times. So for this, there are certain rules that needs to be followed. In fact, for the earliest start and earliest finish time, there is rule 1. For the latest start and latest finish time, there is rule 2. Okay, the rule is easy. The earliest start time for a specific activity must be the same as for later than the latest of the earliest finish times of all the activities leading directly into that specific activity. Okay, so there is a little bit longer reading for this rule, but in fact, the practical implication of this rule is quite straightforward. That means an activity cannot start until all the preceding activities have been completed. And the earliest start time of that activity will be the one which will be after the earliest finish time of all the preceding activities. So in this is in essence the rule is. So this we can see with the help of this diagram. So in this diagram, there are 3 activities. So this activity number 4 uh, has 3 preceding activities, activity 1, 2, and 3, okay? And with their specific durations, okay? Activity 1 has a duration of 5 days, estimated duration of 5 days, and 10 days for activity 2, 4 days for activity 4. So activities 1, 2, and 3 have to complete first before activity 4 can start it, as you can see from these relationship diagrams. Okay, so in out of these 1, 2, 3, and 3 activities, activity 2 takes the longest time. So after 10 days, then the make costumes have been made. Only then the dress rehearsal can start. Okay, so in this case, but within that time, the activity 1 or activity 3 may have already been completed on day 5 or day 4. Okay, so in this case, therefore, the earliest start time for the dress rehearsal activity, which is represented over here, earliest start time, earliest finish time, will be 10 days. Okay, it cannot be earlier than 10 days, because if it is earlier than 10 days, then that means that this activity 2 may not have been completed. So because this activity can only start after the activity 2. So therefore, its earliest start time will be 10 days. So whenever then we will calculate the earliest start time in the forward pass. So we will look at the preceding activities, and whichever activity has the latest earliest finish time, that time will be selected. So in this case, 10 will be selected. So let's start this network calculation. So I can do it over here. Okay, so suppose I have this network. Okay, suppose I have this network. First of all, we need to draw this network. Okay, so first of all, we have to draw this network, and then I can start this. Okay, so so this network can be drawn first based on the activities precedence relationships. Okay, and then we have to draw the perform the network calculation. So can you see this figure clearly?
Yes, we can see.
Yes.
Uh-huh. Okay, so the first activity, you can see what is what can you read it? What is this? Can you
Identify target consumers.
Okay, yes. So you, similarly, you can see you may be able to see all these activities. Okay. Okay. So identify target consumers. Okay. Let me make it a little bit more layout margins and then narrow margins. Yeah, I think we have this way we will have some more space. Okay. So what now I'm doing is I'm going to perform the network calculation. So yes. Okay. This draw. Okay, draw layout is here. So we will start this network calculation starting from the activity identify the network. Okay, identify the. So this one identify the target consumer. So it will be if we start that this is the activity. There is no preceding activity. So we will put the earliest start time here and earliest finish time here. So if it is starting from here, so then we will start from 0. 0 will mean that it will be the first day for the activity, and then we will add the duration of that activity. So it will be 0 plus 3, that will be 3. So this will be the earliest finish of that activity. So because we remember that earliest finish time is equal to earliest start time plus the estimated duration. Okay, so this is the one. So now after that we have this activity number 2, so which is preceded by this activity 1. So we can think about that once the activity 1 finishes, only after that we can start activity number 2. So we can put it start as activity number 3. Sorry, we can put its start time as 3. And then 3 plus 10, that will be 13. So it will finish at 13. So in this way, we have calculated the earliest start and earliest finish time of these first two activities. Remember that 0 over here means that it is the first day. So 0 is the first day, 3 is the fourth day over here. Okay, so uh, we are putting 0 over here because here for manual calculations it is easier for us to do like this, but actually it is the 0 is the first day, which means that it is the start of the first day. Okay, start of the 0 means start of the first day, or in another word, okay, it is the end of the 0th day. So end of the 0th day or start of the first day is the same thing. Similarly, this is 3. This 3 over here means that it is the end of the third day or the start of the fourth day, which is the same thing. Similarly, for the finishing time, so this is the end of the day 3. So basically, in this case, we are using the end of day terminology. Okay, end of day convention. Okay, so this is called as the end of day convention. Okay, so all the activity times shown over here are the end of days conventions. So 0 means end of 0 means start of day 1. Okay, so if the start of day 1, so for example, if it is the 1st of July, so it will be 1st of July. If you will not write it as 0 of July, so 1st of July will be for our scheduling purpose, it will be day 0, but that is the end of day 0, okay, or start of day 1. Anyway, next it will be for the activity 3. So what will be the earliest start time over here?
13.
Yeah, it will be 13. Okay, and then its earliest finish time will be
33.
Yeah, it will be 33. Okay, and then for this one, for the next activity, it will be 37.
Yes.
Yeah, why?
No, 33.
No. 33.
33.
Yeah.
It's not simply that we are just adding this. This is just the activity number. Okay, so therefore it will be same as 33. Okay, and 33 plus 5 is 38. Okay, now here it will be
For all activities, 5, 6, 7, 8, start date will be 38. But the
yes,
finishing time will differ.
yeah, 38 here, 38 here, 38 here. So because all of the activities are starting simultaneously, but their finishing times will be different because each of these activities has the different duration. So it will be 40 here. What it will be?
48.
48, 50, 40.
40.
Okay. And then now here, so what it will be, this one. So mail the questionnaire and the get responses. So now here you can see that what will be the starting time over here?
48.
Yeah. So it can be 48 or it can be 40 as well. But from 40 and 48, we will take the highest time because this activity have to wait to complete all the 2 preceding activities. So for this activity, these two, 5 and 6 are the preceding activities, okay? Because from this relationship arrows, we can see that. For this activity 10 and this activity 7 and 8 are the preceding activities, okay? For 9, 7 and 10, 8 are not the preceding activities. So
Can we take
therefore,
44?
for 48 and, yes, 48. And then for this, it will be
50.
50.
50, okay. Okay, next for this 48 plus 65 is?
50.
So 48 plus 65 is?
113.
108.
13. 113.
3.
113, yeah.
113, okay. 113. So it is 113. And 50 plus 5 is 55. Now for this, what it will be?
113 again.
Yeah.
113. And 113 plus 7 is?
120.
120.
120. Okay, here it will be
120 again.
And 128. And then it will be 128 plus 10, it will be 138. So in this way, you can see that I have written some numbers above each activity box. So these are the earliest start and earliest finish times, okay? So ES and EF. So now suppose that, for example, in this case, what we have found out. So this exercise is for nothing. It's just not for nothing. This exercise is to find 2 main things. So we have found out at yes, yeah, correct. So we have what we have found out. We have found out the total duration of the activity. So this is one thing. This is one main thing. The other thing which we have found out is that we have found the earliest start and earliest finish time for the activity. That means the earliest any activity can be started and finished. Okay, that we have found out. But most importantly, we have found out that the project will take 30 days to complete. 130 days to complete. Okay, so now we can perform some further calculations as well. We already know that the project will take 138 days to complete, but what actually we want is that we want that the project to be completed in 130 days. Okay, so the imposed duration for the project, imposed project duration is 130 days. That means in this case, if we say that imposed project duration is 130 days. So if the project duration is imposed at 130 days, then what do we have to do it? So for this case, we need to also find the latest start and finish dates for each activities. That means the activities may not be delayed later than those days. So for this, what we can do, we can move backward from the project finish date and towards the start. So in this case, if it is acceptable that this 138 days is the acceptable project date. So we can go from 138 days. But in this case, since the project's imposed finish date is 130 days, so we will go back from 130 days. Okay, so let's see it from moving back from 130 days. Okay, so now I have
Professor,
put a number of 130 over here. Yes, you want to say something?
sorry, where did we find the 130-day duration? Where did we get that?
It is the requirements, I guess, right?
Yeah, it's given.
Okay.
Yeah. Suppose I said, okay, suppose I am the customer, I am the client. I say to you that no, this 138 days is unacceptable. Okay, I want the project to be completed in 130 days. So then I think in that situation, I will need to revise my schedule and then consider the 130 days as the latest imposed latest time which is imposed. Okay, so I'm considering that situation. Well, you're right. In normal situations, yeah, we will start from 138 days. But in this case, the customer wants to complete it in 130 days, so we will start it like that. So I'm considering that situation. Okay, so 130, then that is the latest finish date. So if this activity, which is the last activity of the project, can finish in 130 days, the latest. So then it has to start in 120, the latest, okay? Because which is the 130 minus 10, it is 120. So which means that we are using using a formula which is called as the latest start time formula. So latest start time of an activity is equal to latest finish time minus the duration, okay, DUR, duration of the activity. Okay, so in this case now, since from this activity 13 we go to 12, so this will be 120, because if it is to start the latest by 120, then this activity have to finish the latest by 120, and then 120 minus 8, it will be 112.
112.
112, yes, 112. Okay, so similarly 112 here and 105 here. Okay. Okay, so from 105 it will be 105 here, and it will be 100 here, and from here 105 here. Yeah, so I don't have any much space over here, so I will write it like 105. Okay, so this is the here, and 105 minus 65 is 40. Okay, 40 here. And for this, it will be 100, and then it will be 98. And for this, it will be 100. And then it will be 100 minus 12, it will be 88. And for this, it will be 40. And 40 minus 10 is 30, right? And for this, it will be 40. And 40 minus 2 is 38. Remember that this 40 has come from here. This 40 has come from here. So you should go along those relationship lines. So this 100 has come from here, because this activity 7 is related with activity 10. Okay, so now what will be the here?
Do
so
we
one
choose
is
the
38.
worst?
98? 98?
No. So this is 38. This is 30, this is 88, this is 98. This will be out of these four, 38, 30, 88, and 98, we will take 30, the lowest. Okay. When we are going backward, we will take the lowest time. Okay. 30 minus 5, it will be 25. Okay. So when moving forward, we take the highest time, but moving backward, we take the lowest time. Yes. Okay. And yes. And then now here it will be 25. 25 minus 20 is 5. Okay. Here it will be 5. Okay. And then 5 minus 10 is minus 5. Okay. And then it will be minus 5. Minus 5 minus 3 is minus 8. So you can see that in the end, we have got some negative times. So the meaning of the negative time over here is simply that we must start the project earlier in order to complete the project on time, on the target date. Okay. So -8 means over here is that this activity must be started 8 days earlier. So suppose, for example, we are planning to start this project by the start of the next month. That means maybe 1st of February. Okay. But if we start on 1st of February and then from 1st of February 130 days later, we cannot complete the project. So if the target date is to be achieved, then we need to start this project 8 days earlier. Okay, this simply just says like this. Okay, remember that we normally not do this kind of calculation. In the end, what we get is like 0 and then 3, 3 like that. But we can, but there is no no hindrance for us to perform this kind of calculation in which we can show that there is some negative times over here. But the negative times simply show that over here these activities must be started earlier. So, but now you can see that we have done the forward pass and now we have done the backward pass. So doing this forward and backward pass, we have performed some, we have found some new information as this, information as well by the backward pass. So what is the new information which we have found by the backward pass? This in this backward pass, we have found that there are some activities in which there are some activities which needs to be started earlier. Okay, so for example, this activity, this activity. So these are those activities which are showing, and similarly, this activity, okay, this activity. Why we can say that these activities needs to be started earlier? Because for example, this activity 1, the earliest start time was 0, but the latest start time is -8, which means that we need to start this activity early. Similarly, for activity 2 and also for activity 3, because although there is no negative time over here, but you can see that the earliest start time is less than the latest start time. So that means we have to start this activity also early. Activity 4 also needs to be started early. Activity 6 also needs to be started early. Okay, but what is different with activity 5?
It's okay. It should be started
Yeah. So for activity 5, the difference is that activity 5 needs not to be started early. It can be started on time, but you can see that since its earliest start and earliest finish time are the same, it can also not be delayed. Okay, it can also not be delayed. On the other hand, there is a lot of liberty. There is a lot of freedom with this activity 7. Activity 7 can be started as early as 38th day, and as late as 88th day. So we can start this activity as long as like 50 days late. Okay, so activity 7 can be started late. Okay, and activity 8 can be started late as well. But this activity 9, activity 11, activity 12, and then activity 13, they cannot be started late. So therefore, there are certain activities which needs to be started early. There are certain activities which needs to be exactly started on those dates. And there are certain more activities which can be started late, such as activities 7, 8, and 10. So those activities which needs to be started early, these activities are called the critical activities. Okay, these activities are called the critical activities. So in this case, the critical activities are activity 1, 2, 3, 4, 6, 9, 11, 12, and 13. So these are the critical activities. Remember that we are taking a kind of something like a special case. Okay. Normally we say the critical activities are those activities when we just assume the project late finish date is same as the project early finish date, and then we don't get these negative times over here, and then we always get the latest start time to be at least as same as the earliest start time. But in this case, it's just like a special case we are considering. So in this case, what we have over here is what we have over here is the critical activities are activities 1, 2, 3. So, and then you can see that these activities are connected in the form of a path, right? And if we add the duration of the activities along this path, it will be the same as the duration of the activities, which is 138 days. Okay. So, although remember that we want to complete the project by the 130th day, that means there will be some fixed date. This means that if we want to complete the project by the 130th day, then what we can do is we can start the project early, or maybe what another thing we can do is we can just reduce the duration of some certain activities, so that the overall duration of the project may be reduced from 138 days to 130 days. So in that case, then we can start this first activity at the earlier agreed upon time.
Professor,
Yes. Yes.
how did you select these critical activities? Is it just a straight path, or?
Yeah. So so in order to select the critical activities, so we must look at those activities which has the which has the highest, which has the the least slack. Okay, so now there is a concept of slack. Okay, or the float. Okay, so the activities with the least total slack or float. So slack or float are the same things. Okay, least total slack or least total float. So what is the slack? Slack is the total slack or total float is the difference in the earliest start time. So for example, total slack or total float is equal to the difference between these times. So it is the latest start time minus latest earliest finish time. Okay, or it is also the equal to the latest early sorry, this is the latest finish time. Okay, latest finish time minus the earliest finish time, and then this is the latest start time minus the earliest start time. So in this case, if I want to show the slack, then I can show it as -8 minus 0. So it will be -8. That is the slack over here. The slack over here is -3 minus 3 is -8. So we will connect those activities with the least slack in the path. Okay. So -8 is up to now is the least slack. So 5 minus 13 is -8. Okay. 25 minus 33 is -8. 38 minus 30 is 0. So now 0 is greater than -8. So 0 will not be the least slack. So therefore, we have not included this activity 5 into the critical activities. So 30 minus 38 is -8. Okay. And then 40 minus 48 is -8. 105 minus 113 is -8. 112 minus 120 is -8. So I am writing is the total slack. For here it is 88 minus 38, it is 50. So its total slack is 50, so which is quite a lot. Okay, 98 minus 38 is 50. Okay, over here. This is 100 minus 50 is 50 over here. And then similarly, 120 minus 28 is -8.
I'm
So,
sorry, Professor.
yes.
98 minus 38 is 60, right?
98 minus 38 is 60. Okay, thank you. Thank you for correcting me. It should be, yeah, that's what I was wondering, why it's coming as same. So it is 60. Okay, so it is 60. All right, so here now you can see that it is critical activities are those activities with the least slack. Okay, so there so you can either say that the critical path is the longest path in the network. So that means if you take all the paths in the network and then add the duration of the activities along on those paths, and the longest of those longest of those calculations, that will be the duration of the project itself, and that path will be called as the critical path. Or in another word, you can also calculate that the activities with the least slope. Okay, so the critical path means that critical path means that longest path. This is one way of saying, or the path with the least total slack or total float. So slack or float both are the same thing. So this was the concept of the total slack. But the significance of the total slack is that it is the time by which an activity can be delayed without delaying the overall project. Okay, without delaying the overall project. So, for example, in this case, there's this 50 days of slack available. Okay, so if we it means that if we can delay this activity by 50 days, then it will not affect the overall duration of the project. So we can see from here is that if instead of 38, if we see in the earliest start time, if we delay this activity by 50 days, so then it will start at 80 days. So 80 plus 88 plus 12, that will be 100. Okay. So if it will be 100, so the next activity will start at 100. Okay. If the next activity will start at 100, it will finish at 105. Since it finishes at 105, and then the next activity is anyway starting at 113. So it is not going to delay this path in this case. So therefore, by the definition of the total slack, or by, and we can also see from this uh, from this network, is that an activity can be delayed within its total slack without delaying the overall duration of the project. So we can, as we have seen from here, if we just want to update these calculations, then we will see that within its total float, this activity can be delayed without delaying the overall duration of the project. So that was the total slack. And in addition, there is another type of slack which is called as the free slack or free float. Okay. Free slack or free float. Free slack or free float is that path, is that slack, which is different from the total slack, and it is the time an activity can be delayed without delaying any subsequent activity. Okay, without delaying any subsequent activity. So this can happen in certain activities. So for example, and this can only happen in those activities with the which have some positive slack over here. So, or in this case, this, for example, if we say that activity 7, if we see this is the activity 7, over here, and we also consider this activity 10 over here. Okay, and then we also consider this activity 8 over here. Okay, 7, 8, and 10. Okay, and then let me draw these activities again over here. So suppose this is activity 7. Okay, and then this is activity 8. Okay, and then this is activity 10. So what are the earliest start and finish time, earliest finish time of the activity 7? Earliest finish time of activity 7 is
50.
50 and 40, and then earliest start time is 50. Okay, so it is like this: 50, so 50 here, 40 here, and 50 here. So in order to calculate the free float of activity 7, we need to look at its finish time, which is 50, and we also need to look at the start time of the following activity, which is 10. So since these both times are same, so the free float of activity 7 will be 0. Okay, but if we look at activity 40, activity 8, its earliest finish time is 40, and the earliest start time for the following activity is 50. So we can see that if we delay this activity 8 by say 10 days, it is not going to affect the next activity. So we will say that its free float or free slack of activity 8 is 10 days. Okay, so this is how you determine the free slack or free float. So these are the only activities over here which have the free slack. In fact, this activity 5 also has a free slack. So if you can see that its earliest finish time is 40, and its following activity has a earliest start time of 48. So the free slack of this activity 5 is 8 days. But for other activities, the free slacks times are 0, because these are the critical activities. Where when there is a critical activity, then there is no such liberty. So for example, if this activity is finishing at 8, its following activity is also finishing at 3, and then starting at 3. This activity 2 is finishing at 13, and its following activity is also starting at 13. So there is no free slack. Okay. So if I, for example, if I represent this free slack by some other color, okay. So this free slack over here will be 0, 0, 0, 0. And what will be the free slack here?
Actually, Professor, we can't see the pointer, your pointer. So
my pointer you cannot see? Oh,
yeah.
I see. I see. The free slack of activity 5. And now can you see the pointer?
8. Yeah,
Yes.
yeah. Now we can see.
8.
8. Activity, yes, it will be 8. Okay. Yeah, because for the pointer, I'm using some other device, a pen. Okay, so maybe it's not in this system. Okay, so for this, it will be, yeah, so that's the difficulty in teaching online. You cannot express everything. So it should be 0 over here and 0 here. Yeah, that's 50, 50. And then for this 50 and 40. Okay,
It's
so
10.
it should be 10. Yeah, as we have calculated, it should be 10. And for this, it should be 0. And then how about here? Yeah, I think it's there is some, yeah, because it is 55, and the next activity is starting at 133. So there should be a free slack. So 113 minus 55 is
68.
68.
58. Yeah, it is 58. Okay. Yeah, it is 58. So 50 plus 5 is 55. So 50 plus, so it is 58. Okay. Okay.
Professor, I'm sorry. I think that it should be 68.
68. Yeah, by some calculation, yeah, it should be 68, right? Okay. So 113 minus 55 is 68, right? 68. Okay. And then it should for this one it should be 0, and then it should be 0, and then it should be 0. Okay. Okay. So is everything correct? I think it's the
58, Professor.
58. 58.
Yes,
So
yes.
113 minus 55 is 58, right? Yep. Okay. Yeah, it should, because if we take 113 minus, if we take 113 minus 55, this is 58. Okay.
Yes, I'm sorry.
Yeah, 58. Okay. But in this case, so if it is 58, then it is 50. Okay. So, yeah. So this is the free slack. Anyway, so in this way, we have completed this free slack. So let's go back to this PowerPoint. Can you see the PowerPoint?
Yes.
Okay. So first of all, we start from the identify the target customers, consumers. So we start calculating the durations, and then the network is developed, review comments, and finalize questionnaire. So, and these slides are just showing those calculations which I have just shown to you over here. And mail questionnaires, test software, input response data, analyze results, prepare report. Okay. So once you complete the forward pass, you can also create this table. So this is the list of activities, and of course the responsibilities, their estimated duration, and then you can input the earliest start and finish times from the network in this activity. So this is called as the schedule table for the earliest start and earliest finish. And then later on, when you do the backward pass, then you can also calculate the latest start time and the latest finish time. So for this, we will apply the rule 2. So the latest finish time for a specific activity must be the same as or earlier than the earliest of all the latest start times for all the activities emerging directly from that specific activity. So here you can see that and if these are two activities, okay, and there is one activity preceding these two activities. So the latest finish time for that activity will be the earliest of the will be the lowest of the latest start time of these two preceding activities. So if it is one is 20, the other is 25, so you will take 20. Okay, you will take 20. So in this way, then you will complete the backward pass. So for each of the component, the backward pass has been completed. So in the end, we are getting a -8 as the earliest start time of the first activity. So it means that the project is 8 days late at the start, which means that we need to start early by 8 days, or somehow we have to reduce the overall duration of the project by 8 days to make up for this delay. So in this case, we get this latest start and latest finish time. So all those latest start and latest finish times can be input into this schedule table. And then there is the concept of the total slack. So it is also called as the float in some other books. So it can be a negative slack or it can be a positive slack. Negative slack means that there's lack of slack over the entire project. The amount of time and activity must be accelerated. And the positive slack means it is the maximum amount of time that the activities on a particular path can be delayed without jeopardizing on time completion. If we have just take as a simple example, the total completion time for the project is 28 days. So for example, if this is the 7 plus 5, 12 plus 3, 15 days, the required completion is 20 days. Okay, that is if there are 3 activities in this project and you are asked to complete the project in 20 days. But if you add up the duration of these 3 activities, that is 7 plus 5, 12 plus 3 is 15 days only. So the project has a 5 days of slack. So in this case, this 5 days of slack in the project does not mean that it has the slack in each activity. So for example, if any of the activity uses that 5 days, the slack in other activities will be finished up. Okay, so the other activity cannot use the slack. So it means that the slack on activities in a path are basically the shared slack. So for example, if there is a total slack of say 5 days in this case, one of the activity can use maybe 3 days of slack, the other activity may use the 2 days of slack, and then there will be a third activity, and then that third activity will not be left with using any type of slack. So the concept of slack in the activity is basically the concept of a shared slack in the path. So the critical path, it is the longest path in the overall network diagram. And then it, in this case, how we can find it? We can find it by those activities which have the least amount of slack. So in this present project, we have found out that this was the critical path that we have just identified. So it was 1, 2, 3, 4, 6, 9, 11, 12, and 13. Okay, that was the critical path, and that path was having the least slack with -8. -8 was the least slack, and the slack we can see that slack we can easily find out by subtracting out the earliest and late start times. So here you can see that the change in slack for the critical path. Yeah, this is the situation when, for example, in this case, in the original case, if you see, this was the longest activity, mail questionnaire and get responses. This activity is here, 65 days. So if we want to complete this project early, and then we are thinking that how we can complete this project early. Instead of 138 days, we want to complete it in 130 days. So then in this case, we can look at the activities, and then first thing we can maybe look at, we can see that this is the activity with the longest duration, 65 days, and it is about the mailing the questionnaire and getting the responses. So that product team may think that perhaps we can expedite this work on this project instead of getting the responses and giving the responders more time to answer the questionnaire. We can give them less time to answer the questionnaire, and instead of taking 65 days, we can complete it in 55 days. So if we change its duration from 65 to 55, then some changes will happen in this project. Okay, and these changes can be reflected in the change time of for the duration of the activities. So in this case, if we change the duration from 65 to 55 days, the project will complete in instead of 138 days, the project will complete in 128 days. So which is represented over here. Okay, but since we want this project to be completed in 130 days, so we can go do the backward pass with the 130 days as the latest finish date for the project. And in that case, we will get a positive slack in all activities, positive slack in all activities. But by the definition of the critical path will be that path with the least slack. So in this case, the least slack will be 2 days. So critical path will remain the same in this case. Okay. And then there's this concept of the free slack. So it is a time a specific activity can be postponed without delaying the earliest start of its immediate successor activities, immediately following activity. So, and we have seen that how it can be calculated. So for example, the free slack of the activity 7 was, the total slack of activity 7 was 50 days, total slack of activity 8 was 60 days. So the free slack of activity 8 was, which was over here, which we calculated over here, was 10 days, okay? In this case, which is basically these earliest start time of the succeeding activity minus the earliest finish time of the preceding activity. And we can finish quickly. Okay, so we have reached up to this point over here. So yeah, so we have left with some a few of the more slides as well, but the time is almost gone now.